I find smoke detectors a marvel of engineering. Let me show you how it works. This black cylinder has louvers which guide air into the detector. Now it hides the essential part of the device. Tucked in here lies about 1 microcurie of radioactive americium-241. That's about 0.29 micrograms. That tiny bit of radioactive material generates a small current that makes the detector work. Let me explain how. Air flows between these two electrodes. Now, of course, air doesn't conduct electricity, but when alpha particles from the radioactive americium slam into the oxygen and nitrogen molecules that make up air, they knock electrons about, leaving charged gas molecules. The 9-volt battery causes these ions to move, thus creating a current. Now, here it's tiny, something like 100 picoamps, about 100 billionth the current flowing in your home. When smoke enters the chamber, the ions attach to it and slow down and often lose their charge. Both events cause the current to stop, which triggers the alarm. Now, to make such a compact thing work with only a 9-volt battery required the solid-state revolution of the 1960s. Let me show you. If I remove the two electrodes, you can see a small integrated circuit. It incorporates a marvelous device called a MOSFET, which can detect those very small changes in current. In the detector, it serves as an on-off switch triggered by the tiny current between the electrodes. Like every transistor, its operation depends on being able to make diodes from semiconductors. Recall that a diode allows current to pass in only one direction because it uses two types of semiconductors, a type that uses negative charge carriers and one that uses positive charge carriers. Flip that battery and the flow of charge stops. Now, to build a MOSFET, we take two such diodes and put them together so that each is reversed. Now, this seems useless because no current will ever flow through such an arrangement, but engineers embed this diode sandwich into the same type of semiconductor as the diode ends that touch. Then they place metal contacts at the ends of the diodes and on the block of semiconducting material. Next, they coat the diodes with a thin layer of silicon dioxide. Unlike metals or semiconductors, this doesn't conduct electricity at all. On that, they place one more metal contact called the gate, which opens or closes the current channel between the source and the drain. When we create a voltage difference between the gate and the source, it generates a field through the insulating layer that draws the free positive charge carriers toward the gate, opening a channel that now allows current to flow. In a circuit, we use the 9-volt battery to generate a potential difference between the source and the gate. It biases the gate so that the current flows through the MOSFET, thus turning on the horn. So we counter that with a current flowing from the detector. Here is where the ionized gas creates the tiny current between the two electrodes I showed you earlier. That current passes through a large resistor and creates a voltage that opposes the battery, and it shuts down current flow through the MOSFET. If smoke enters the chamber, the tiny current stops, the MOSFET allows current to flow in this section of the circuit, which triggers the horn. Now, to me, this is engineering at its best. Simple, reliable, and inexpensive, and saving countless lives.
Hi, I'm Faith Greenwell, a homeowner and employee at US Inspect. Let's talk about smoke alarms. Well, Keith, tell me about smoke detectors. How can I be assured that it will work when there's a fire?
That's a great question. Smoke detectors today are very sensitive. So if there was any type of fire in the house and the smoke made it to the detector, then obviously it would go off with a very loud, audible alarm to hopefully wake you up so you can get out of the house before anybody gets hurt.
Okay, so how do I test it and how often should I test it?
Once a month, you should come right over here and press the test button. We're not going to do that right now because it'll get everybody's attention.
Right.
But you just test that once a month.
Okay.
And you should change the batteries twice per year. An easy way to remember that is whenever the time changes, change your battery.
Bring forward, fall back.
Exactly,
Okay.
exactly. Just change your battery whenever the time changes. That way you won't forget.
Where in the room should it be placed? Like on the wall or the ceiling?
First of all, you should have one on at least every level of the house.
Okay.
Second, you should have one in every sleeping bedroom.
Inside the bedroom?
Inside the bedroom, preferably. Additionally, it's a good idea to have one in the hallway that adjoin the bedrooms. And as far as the position of the smoke detector goes, if it's wall mounted, you want that between 4 and 12 inches from the ceiling.
Oh, okay.
Okay, so you want it at least 4 inches down from the ceiling, but no greater than 12 inches down from the ceiling.
Okay.
If you're actually going to mount it on the ceiling, then you want it no closer than 4 inches from the wall.
Okay, so location does matter.
It does, it absolutely does. And as far as maintenance goes, what you want to do is periodically vacuum them. Okay? Just take a little vacuum and just kind of suck the dust out of them, and that'll keep the sensors in them clean.
Okay.
So it'll ensure that they do in fact activate when you need them.
And then should you ever change the smoke detector?
Yes, these don't last forever. The manufacturers, most of the manufacturers recommend that you replace them every 10 years.
Oh, good point.
So a good little tip is, on the back of it, with a magic marker, you know when you bought it, put the expiration date on it, 10 years from the point in which you bought it.
Okay,
right on the
good
back
idea.
of it. So that way when you're changing the battery 10 years from now and you go, oh my, this is expired, I need to replace this.
Right.